Now, the greatest assumption that we have done, or greatest assumption that we have made, is that the university has launched similar kind of credit cards in the past. All right, if I take you guys back to this case study, if you look at this, you had 100,000 people, and it's also given that population standard deviation is so much from previous launches. So previously your university has launched a similar kind of credit card, and based on that, the average balance of 100,000 people happens to be $2,500. But in majority of the scenarios, you will not have this value. Maybe university is trying to launch for the very first time. So you would not have the previous launch details. In such a scenario, this value, population standard deviation, which is sigma, would be unknown. You'll not come to know about sigma, right? Then what do you do? Then this formula does not apply or does not hold good, because this formula is z1 minus alpha into sigma over square root n. If sigma is not known, then what would we do? And that is when your another probability distribution called as t distribution would come in handy. Right? T distribution would come in extremely handy. All you're trying to do is the sigma is being replaced by S. That's it, simple. This is a formula to calculate T. This is your sample standard deviation, if you remember, from the initial tutorials. Now, don't worry too much. Let us solve this. So the T distribution would come in handy for us. So once again, I repeat, if sigma is known, until now we have used Z distribution to calculate the confidence interval. However, if sigma is unknown, you go with T distribution. And in the Z distribution, there is another condition saying that your sample size should be greater than 30. And for T distribution, if sample size is greater than or less than 30, in either scenarios you can proceed with this T distribution. All right. Now I want to explain you all a small concept called degrees of freedom. What does this mean for this T distribution? All right. Though this is fairly a complex concept, I'll try to explain in simple terms, and I request you all not to look at the loopholes, rather try and understand the concept. Say you want to choose 4 people in such a way that the average experience turns out to be 5 years. And you want to choose people whose experience is in between 1 to 9 years. So you can either choose, for the first person, you can either choose a person who has 1 year experience, or 2 years, or 3 years, or 4 years, or 5 years, or 6, or 7, or 8, or 9. So you have complete freedom to choose any person for the first position. Say you have chosen a person with 8 years of experience. Say you want to choose the second person with some years of experience. And say you have chosen a person with 2 years of experience. You can choose either a person with 1 year work experience, or 2 years, or 3 years, or 4, or 5, or 6, or 7, or 8, or 9. So you have once again complete freedom in choosing a person for the second position. Say you are choosing a person who has 2 years of work experience. For the third person also, you once again have complete freedom. You can choose a person with 1 year work experience or 2 or 3 or until 9. Say you are choosing a person who has 7 years of work experience. So you have complete freedom in these 3 scenarios. Do I have complete freedom to choose the fourth value such that the average work experience happens to be 5 years? Absolutely no. You have to choose only one value here. You do not have any freedom. You have to choose only 3. Only if you choose 3, the average work experience happens to be 5 years. It'll be 20, right? 8 plus 2, 10, 17, 20, 20 by 4 is 5 years. If I have any other value other than 3, I would not get this 5 years work experience. So what does that mean? For 4 values, how many degrees of freedom do I have? In how many positions do I have complete freedom? 3 positions. And in 1 position I do not have freedom, so it is -1. That means in 3 positions you have complete freedom. And in that scenario, if I have n values, then I would have n minus 1 degrees of freedom, right? And for each calculation, very important, for each calculation 1 degrees of freedom is taken away. So if I have another calculation, it will be n minus 2. If I have another calculation, it will be n minus 3. In that way, for each calculation, 1 degrees of freedom is taken away. Though it's a complex concept, I try to explain, in a layperson terms. All right. Now, one more thing that you need to understand here is that research has shown that the t-distribution is fairly robust to deviation of the population of the normal model. What does that mean? Let us understand here. The formula for degrees of freedom is equal to n minus 1. As and how I keep increasing this n value, that is, as and how I keep increasing the sample size, degrees of freedom would also increase. If I increase the sample size to 10, so 10 minus 1 would be 9. If I increase the n value to 20, 20 minus 1 is 19. So as and how I increase the n value, the corresponding degrees of freedom also would increase. That's one thing. All right, look at this. This curve that you see here is of standard normal distribution. And this curve that you see here is t-distribution. This t-distribution is also called as student's t-distribution. For degrees of freedom equal to 1, that is sample size of 2, there is a lot of dissimilarity between your standard normal distribution and your t-distribution. But if I increase the sample size, degrees of freedom also would increase. As and how degrees of freedom increase, you see that the difference has slightly come down. This is your standard normal distribution, and this is your t-distribution. In that way, if I increase the sample size further to 11, I get degrees of freedom which is 10. Now, if you notice clearly, there is negligible difference, though there is small difference that you notice. If I increase the sample size further to 30, you see that standard normal distribution and t-distribution overlap. What does that mean? As in how your sample size increases, degrees of freedom increase, and the t-distribution approaches standard normal distribution. So for larger sample size, you can assume that your t-distribution follows normal distribution, and you can proceed with all the analysis that are possible for normal distribution. That's advantage. Now, this is a key thing here, right? If sigma is known, you employ this formula. wherein this part is called as margin of error. All right. Now, if sigma is unknown, then you need to go with t-distribution, which is also called as student's t-distribution. And the formula is as follows. Same, it's more or less the same. It's x bar plus or minus this margin of error region changes. Since you do not know sigma, it's s over square root n. Here you have z distribution, here we have t distribution. That's the only difference. All right. Now, let us actually solve that university case study. In that university case study, we are given all these values that the sample size is 140, sigma is, for sample it is $2,500, average happens to be $1,990, and S was for sample, right? Sample standard deviation. That was given as $2,800. Sorry, $2,833. Now let me erase that. $2,833. And what was the formula for t-distribution? X bar, point estimate, plus or minus t, 1 minus alpha n minus 1, s over square root n. So this s over square root n is solved for us as 239.46. X bar is given as $1,990. So the only value that we want to calculate here is this. And say we want to construct a 95% confidence interval. Say you want to construct a 95% confidence interval. So t, 1 minus alpha is 95%, which is 0.95. And n minus 1 is sample size minus 1. Here it is 140. So 140 minus 1 would be 139. And how do I calculate this? In the previous tutorial, we have discussed about how to calculate z value from z table. And here we'll be calculating t value by looking at t table. Let me take you all to the t table. Okay. So all you need to do is just do a Google search. So let me open a new one. Let me close this. All you need to do is type t table. You'd get the t table here. So let me, yep. I'll choose a red color which is prominent. So we need to solve t 1 minus alpha n minus 1, which is t 95% and 139, right? N minus 1. Now 95% is given here towards the bottom of the screen. Degrees of freedom is given here. Degrees of freedom is 139, but we have 100, post which we directly have 1000. Why is there such a difference? Why don't we have degrees of freedom for all values? Because if you look at the difference between degrees of freedom 100 and 1000, the difference is negligible. Look at this, 0.002. That's negligible. If the difference between 100 and 1000 degrees of freedom is 0.002, imagine what would have been the difference between 100 and 139. It would have been minuscule, right? Hence, 139 can be approximated to 100. And now let us traverse in this way. Come on. Yeah. So if you traverse in this way, and for 95%, if you traverse in this way, this happens to be your value. So this is equal to 1.984. And that is exactly what we got, 1.98. and you just need to apply that in the formula there. So we need to solve this, and if we solve this, the formula would be x bar plus or minus t1 minus alpha comma n minus 1 s over square root n. X bar is given to us. Yeah, you can also expand this formula as x bar minus t1 minus alpha n minus 1 s over square root n in x bar plus t1 minus alpha n minus 1 s over square root n. If you want to expand this, x bar is $1990, so it is 1990 minus t1 minus alpha n minus 1 is 1.98 and s over square root n is 239.46. And here you have x bar, which is 1990 plus t1 minus alpha n minus 1 is 1.98 multiplied with 239.46. You get some value. I'm assuming that it should be equivalent to this. All right. In the assignment that would be provided to you all, you'll have to construct a 90% confidence interval and 99% confidence interval. Right? So remember this also. From the z value in the previous tutorial, we have calculated the probability value either using z table or using the R function called p-norm. Yep. Here, oh sorry, q-norm, my bad. Using q-norm, not from z value. So from probability value, if you want to calculate the z value, we use the function called q-norm in R. And if you want to calculate the t value, formula would be qt. Z is standard normal distribution, hence it's normal, q-norm. Here it is t, so qt. Let us try to solve that. So 0.95 and 139. So it's qt basically. Qt of 0.975 comma 139, it is going to give you 1.98, and that is exactly what we have got. But if a few of y'all are wondering on why is it 0.975 and why is it 139, it is t 1 minus alpha n minus 1. So n minus 1 is 139, 1 minus alpha is 95%. But once again, if you draw the curve in this way, if you want to calculate the confidence interval for 95%, there's a 5% chance that you might go wrong. Since there is an equal opportunity, here you'll get 2.5%, here you'll get 2.5%. Then you need to consider the entire region towards the left, which is 95% plus 2.5%. which happens to be 97.5%. If you want to represent that in number format, it's 0.975. All right.